In this video, I'm going to show you how to find the limit using the wall method. Now, there are three types on how to find the limit. The first type is the wall method or the graphical approach. The second type is by table or numerical approach. And the third type is through an algebra approach or algebraically. So what is the wall method? First is we need to understand what this graph is about. Okay, so let's say that this graph refers to the function f of x. Okay, so this pink line I'm talking about is f of x. Okay, now f of x is represented by this equation, x squared minus 1 over x minus 1. Okay, so f of x is also called the function. Now, in the book, you might see it as the limit of f of x as x approaches, say, 1. Okay, so we can write our notation in this fashion, where f of x is represented by x squared minus 1 over x minus 1, or we can write it as the limit as x approaches 1 of actually writing the function down, which is the x squared minus 1 over x minus 1. Okay, so either way, so I can write it in this form or I can write it in this form. So in this example, I'm going to write it in this form. Okay, and for example 2 and 3, I'll write it in this fashion. So what is this saying? So it's asking us that what is the value? What is the limit going to as x approaches 1? Now, we have to be careful because this is talking about two particular things. What do I mean by that? So when we have the limit of f of x approaches 1, we have to consider two scenarios. One is, what is the limit as x approaches 1 from the right side? And then I still have f of x here. And what is the limit as x approaches 1 from the left side of f of x? Okay, so so when you see this notation, it's actually asking for two parts. Okay, unless it says specifically, it's written as this form or in this form, and then we just have to worry those, it's called one-sided limits. Okay, but if it's written in this general form, then we have to consider both of the areas, both of the sides. All right, so what is the wall method? Well, the wall method basically is, okay, I need to find out what x is 1 at. Okay, so 1 is right here. Okay, so here's my x value, here's my x-axis, and here 1 is right here. It's right here. Okay, and I'm trying to figure out, okay, what is the graph, what is the limit going to as x approaches 1 from both sides? So one easy method to calculate that or to figure that out is using that wall method. Okay, so basically at x equals 1, at 1 here, I'm just going to draw a wall. Let me use a different color here. Okay, so here's my wall. So I need to figure out, okay, what is my limit or my y value approaching as x approaches 1 from the right and 1 from the left side? So let's figure that out. So if here's 1, if I'm approaching 1 from the right side, what is that limit going to? What is that y value going to from the right side of 1? So notice that as x approaches 1 from the right side, it's approaching the value 2. Okay, so I'm going to write down here this is going to 2. I'm going to do exactly the same thing the left side now. So as x approaches 1 from the left side of the wall, okay, as it approaches the wall here, what is that y value going to? It's also going to 2. Okay, so in this case, I'll write 2 here. All right, so before I declare what my answer is, again, the plus sign here indicates it's going from the right side. We're looking at the right side of the graph. The negative sign here is indicating we're looking at the left side of the graph. Okay, and if they both go to the same limit, then we have or the same value, then we have our limit. So since both of them are going to 2, then our limit in this case will be 2. So, but remember, when we see this general form, we have to break it up in this fashion. One looking at the right side of the graph and the other looking on the left side of the graph. On the next video, I'm going to show you how to find the limit of this particular function using the table or numerical approach.